Hello, this is Christian, NeverEngineLabs. I'm just going to do a quick kind of workflow run through for using my ReadOSC class. Just pull it up. I haven't really prepared anything beforehand, so I'm just going to run through and whatever comes up, but I'm sure it's going to be useful where to refer to. So what I'm doing right now is working on a complex composition with lots of automation data, in this case controlling spatial information. And I was thinking about perhaps starting to try to see what Kyma can do with that information if I send it to Kyma, and perhaps in preparation for the wireframes lab that's just opened at NeverEngineLabs, we may be able to research some or come up with some ways of sort of recording multiple streams of OSC information. I think that could be quite interesting. But for starters, let's see how to set up a situation where Kyma is receiving lots of OSC. Let's go through that. I think here's my basic class, which is when you open it, it's already got some examples of how it works. In this case, it's an example of how to work with it with eAnnex. Of course, like all of our classes at NeverEngineLabs, got full documentation, but you can always drop me a line when you have any questions as you're using it. So one of the important plugins that we've been using when working with OSC, developed at EarCam, is the TOSCA plugin, which is free and available online. You can go and get it from the EarCam website. And it is quite straightforward to use, but it allows you to, it's also unique and powerful because it allows you to send automation data to and from your DAW as OSC. It works with an XML file that you need to configure. You'll be reading the, if you use TOSCA, you'll already be familiar with this. It's actually quite straightforward, and you just assign OSC messages and ranges to a set of kind of dummy faders inside the DAW repo in this case, and the DAW just automates that stuff, and TOSCA routes it out to an OSC receiver. I find it useful to route through osculator simply because I get to see what's going on. But you can also route directly to Kyma, which is what I'm doing at the moment. The way I'm doing it is also using a sort of extra feature of osculator, something that Camille Triard wrote called, I just have to find it, it's a command line utility called oscbroadcast, which is really useful because it basically opens a port, a listening port, in this case 9100, and then splits whatever's coming into that port and duplicates it over any number of ports. So it's like a kind of a splitter cable for OSC, which is also really cool. It's called OSC Broadcast. You can get it from the osculator site. It's free as well, but very useful. So I've just set this up to route any messages that are sent to 9100. As you can see here, TOSCA is sending to 9100. So whatever's received on 9100 will go out to localhost 5100, which is actually this oscillator document. So I'll see the messages there, which is nice. But I'm also sending this /t, means transmit, to the IP and port number of today's IP and port number of my Pacarana. So it will also send those messages direct to Kyma. That's a pretty neat and very powerful utility. So if you're into some advanced OSC setups, definitely check out OSC Broadcast, very useful. And what's happening is whatever TOSCA sends will come up in that window and also be sent to Kyma. So let's take a look at what's going on. I've just put this arrange into a loop. You won't hear anything. It's top secret what I'm working on, so you won't hear it. So here we should see that messages are coming in on 5100, because here TOSCA is sending them to 9100, which, if you remember, is the listening port of the broadcast utility, and the broadcast is forwarding those messages to 5100, which is this. We should see some messages somewhere. There's not much going on right now, but I do know they're coming in. And then it's also forwarding them to Kyma. So let's see if Kyma is listening. And the way to do that is to configure the NeverEngineLabs ReadOSC to receive all those messages and then generate some events based on them. Now, as you can see, there's lots and lots of messages. There's 18 objects, and each one has a common structure of auto/source/pos/d for distance, or E for elevation, or A for azimuth in this case. That's what I'm working with. And there's 18 objects, so you can see it's the same core message with a number on the end. Now, we don't need to copy and paste all those messages in. We're going to do this little advanced trick, which is to use Smalltalk to do it. So what I do is copy the common stem like this. Then I choose a voice number variable, because what I'm going to do is replicate this instance 18 times, right? This is you have to put parentheses around. If you don't put parentheses around, I'll show you in a second, you'll get a weird error. Right, so we can just copy those three common messages. What is it? Auto source pos E, auto source pos D, and auto source pos A. So I need to put a \E, \D, \A, \. Okay, that very simple bit of code has constructed all of the messages. Now, don't run this sound yet because it's not ready, so we need to also match the same amount of generated events as there are OSC messages, arguments, which 1, 2, 3. There's actually 3. If I had put 3 Fs here, there would be 1, 2, 3, 4, 5 arguments. Anyway, that's all in the docs. If it doesn't make sense right now and you're owning the ReadOSC, of course everything is in there, and there's a manual I wrote as well to try and guide you. But for the sake of this video, I'm going to go a little bit faster. So we basically invent some events that we want to see in the VCS to represent messages we're receiving. So let's say elevation, let's say distance, let's say azimuth. Okay, so these are the 3 generated events. Of course, we need 18 times 3, so what we're going to do is replicate this instance. This is the important part, which is why I wanted to make this video in the first place, was just to show you how to do this safely, meaning not to clash generated events. So what we need to do is replicate 18 times, right? Make that nice and big. I'll try and run it now, but this is, see what happens. Probably, right, we do get lots of faders, and they have been constructed in a way, but they're not receiving the messages that should be sent to it. Let's just check. Yeah. Now, why is that? The reason is that there's a renaming going on in the replicator that needs to be taken care of. It's basically renaming the OSC messages in the background. You don't see it, all you see is the generated events, so that's why you might get this situation where nothing's working. This is the correct procedure. It's to click rename special events in the replicator. It's to copy those generated events. I'm copying them and I'm going to paste them in here, and I'm going to say, right, I want the generated events to be renamed only, but everything else will not have a renaming. I think that's the right way around. Let's take a look. No, it's still not going. So is it the other way around? Could be that it's just not got the right syntax. So I do need to rename. I had it going earlier, so let's just take a look at that. Oh no, I didn't save it. Great. I think it's here. I did have it right. It's just we need to rename those special events. Correct. We also need to remap them. But I'm a little confused as to why it's not going. Is it that this somehow is TOSCA is not sending anything? Let's take a look. Ah, yeah, OSC broadcast isn't running, so I actually have to run it. Then it starts to send. Okay. Now we see messages there in the osculator, which is cool. And we'll probably see them in Kyma. Sorry about that. Like I said, I wasn't going to rehearse this beforehand. Just do it on the fly. So that's correct. It was right what I was saying. You need to rename special events, paste in the generated events here. Okay, let's remap them as well. Elevation, I happen to know, goes from the XML. It goes E is from 0 to 90, right? Distance is from 0 to 1, and azimuth is minus 180 to 180. So let's just reflect that. We know that they're coming in from 0 to 90, the elevation. The distance is coming in, what was it? 0 to 1, 0 to 1, and the angle is sort of full circle, minus 180 to 180. And then they will get remapped internally to whatever you want, 0, 1. I think I want to keep azimuth and distance normalized to 0, 1, but I want to elevation and distance to 0 to 1 and azimuth to minus 1 to 1, a full range signal. I'm thinking about this idea of making a recorder. But anyway, let's see if that works now. Run it. We should see some moving widgets. There we go. Wonderful. So Kyma is currently tracking all of the OSC being sent from the DAW. You could do some tidying up here. Here's a little trick or two when you get lots of widgets. Do not resize when Windows size changes, then open the window a bit. Then you get a bit of space to select them all up in one go, like that. So let's select all azimuths and, I don't know, make them a bit smaller, make them rotaries, make them minus 1 to 1, which is the correct range for the azimuth. Squeeze a bit of horizontal, squeeze a bit of vertical, nice, and so on. Oops, got to keep shift pressed to shift select, and do the same trick with distance. Squeeze a bit of horizontal, squeeze a bit of vertical. Neat. And now we've got some Tetris style going on. Elevation can stay like that. Just squeeze the horizontal a bit. Yeah, could be like this, for example. Why not? Whilst we're here, I'll show you another trick, which is to duplicate this layout. I've got a copy of it here, and I tend to rename it and call it Widget Designer or something like that. So it's basically, I can see there's 18 versions of the widgets, so there's a nice shortcut in the VCS editor, which is to do a cleanup and say I want to clean up with 18. Then you get, look, 3 rows all correctly organized like that. That's also a handy tip. And whilst we're here, here's another really cool tip. Oops, close that. I didn't mean to do that. No, do it again. It's to say, I just wanted to select them all, make them a bit smaller. Okay, you can do this to, you can go through, select them in this order, 3 at a time, in that order, like that. So from azimuth to distance to elevation, azimuth to distance to elevation, and before long you'll be able to make it into a 3-dimensional cube. Representing those values might be useful for you. Anyhow, I'll just wrap that up now. Just to recap it, here was a very simple bit of programming, very straightforward, just a few things to take care of, which is to make sure that the special events are being renamed like this. And you've basically got Kyma listening to 18 times 3 messages, right? So that's like 54 messages. All right, let's see what we can do with that next. That's it for now. Thanks for listening.